Hello everybody. Ronald here again. So got a request after I posted last video where I was sort of previewing a GPS tracking system. So I got a request to sort of do a series, right? So I've never done a series before. Actually, I never really done like a really long video where I'm just talking. I don't think I've done one of those, but I've done a couple presentations here and there outside of the scope of this context. So today what I'm going to attempt to do is to walk you through the back end of that tracking system. So if you didn't watch it, then you can always go over there and sort of watch it. It's a brief, it's a brief and sort of a rough walkthrough of the system. Apart from that, there was nothing else to that video. So when I got the request, and right now I'm going to try to deliver to that. So let's get to the back end, shall we? So in the back end, the tools that we have, or the tools that I used actually, is Django, right? I use Django with the Django channels, right? Django channels package, and the GIS, is it Global Information Systems package, which sort of comes with Django, I think. Yeah, sort of comes with Django. So let's get to it. I already had PyCharm running right here. Let me open this in VS Code actually. This is the second take of this. The last take was like 2 hours, and I realized that the sound on both my laptop and my desktop was terrible. So I'm on my desktop now, and I think I just managed to fix it. I'll be keeping an eye on it for a while, but let's hope it works. Okay, let me get closer to this. Get comfy. Right, so let's come right here. Stretch this out a bit. Okay, so we have channels, right? On our installed apps, we've got channels right there, right? Django channels, put it at the top. So when I was putting this thing together, I ran into a post where someone said when you're using Django channels, it's best to have it at the top, just so that you avoid conflicts with I think it's with WSGI. So ASGI and WSGI, in case you want to run those two together or at the same time. So something along those lines. So I had to put it at the top. GIS, you need to add that. You need to install course headers, your REST framework, auth token, and REST framework GIS. You need that. Start, right? If I run this, I'm not sure if I can run it right here. Run server. So the start app is just the view of the app that you see when you load it up, sort of the home page actually. Very rudimentary, and there's nothing to it besides a bit of text. User. I think Google Chrome is going to start acting up again, chewing my RAM. Anyway, User, that's our user right there, right? Where our user is, our user model is, and our auth user model is, right? And all the nuances and the intricate workings of that. I'm pretty sure if you're watching this, you already have an idea of how that works. So I'm going to skip user. I'm not going to dive into that. Package, I'll walk you through package as I walk you through the tracker, right? The track. So the backbone of this whole system, or not necessarily the backbone, but the main part of this whole system, right? The star of the show is, as I'll call it, it's this app track, right? It's this app track. So that's what we're just going to dive into, just so that I don't waste anybody's time here. I really hate wasting time. Default authentication classes, I'm using token authentication. You can use JSON web token and so on and so forth. It's up to you to decide. Permission classes, we have all of these permission classes, but the ones that I use most are these two. Pagination class, you have that pagination class, and default page size is 50. So we've got middleware, course headers, right? Course headers middleware and course middleware. Root configurals, we have that. Templates, we're going to skip that. We have our database, and then we have our course header and configuration, cross origin resources, right? Or cross origin resource scripting. I think that's what it is. So again, if you've worked with Django and the DRF, you most probably have an idea of how to do this. And so before we go any further, I need to explain that this whole system, it's split into two parts, right? There's the front end and the back end. The back end is an API, yes, and which is what Django is doing. So we have an API, and then in order to do live tracking, you have to upgrade your current HTTP, or you have to upgrade an HTTP request in order for you to be able to do that. So that's one part, right? That's keep that in mind. Keep that in mind. So that's settings. I'm not going to go into much of this part. I'm not going to go into a lot of things, right? So let me jump to ASGI. ASGI. In order to configure your ASGI properly, please read the Django channels documentation. You will get an idea of what's really going on. But just to explain it to you, right, lightly, right, just so you can be able to implement it. We have a protocol type router, right? So protocol type router, I'm pretty sure it's the name actually speaks for itself. Protocol type router. So protocol type router, it handles routing based on protocol, right? So HTTP will say if it's an HTTP request, it will run the get ASGI application, right? So you will send that request to the ASGI application. WebSocket would be handled by auth middleware stack, which auth middleware stack it's a number of plugins and modules, I think, that have been put together just to put together the auth that middleware stack. So apparently, if you were to implement the auth middleware stack on your own, it would take a really long time. And then we have our URL router, and then we get our WebSocket URL patterns, right? So if it's HTTP will run through here. If it's WebSockets, a WebSocket will run through here. So it's one really good part. Next, let's leave this ASGI and let's go to our WebSocket URL patterns, right? So WebSocket URL patterns are in our track app, right? So we're going to skip over all of this. We're just going to focus on how we're handling the WebSocket connections and how like I say this, like we're going to handle I'm just going to focus on how the WebSocket connections work, right? Or how I've used them in this context, right? So we're going to go to track, and we're going to go to routing, and here we are, right? So WebSocket URL patterns, right? So WebSocket URL patterns, of course you could have called this anything you wanted. I just called it WebSocket URL patterns. You can always change the name and name it whatever. In this context, it doesn't really matter. So I have two paths, right? So if you're paying attention, like previously, pay attention now, because it's about to get a bit messy. We have two paths, right? We have two paths, and these two paths, they have keyword arguments. The first path has keyword argument, one keyword argument in it, and the other one has two keyword arguments in it. So why is that, right? Like why would I have implemented it like this? So initially our focus was on two things, right? The tracking device and the platform, right? And the front end, right? The front end of which the users will actually interact with. That was our main focus, right? So let me get into how I actually made that happen, right? So this is views, serializers, routing, consumers, right? Okay. So in consumers, right? In consumers, get to that right now. We're getting to how we made this happen. So with consumers, right? Consumers are sort of if you don't think of them like a layman terms, or in a simplistic manner rather, you can look at them as views for Django channels, right? They are like views for Django channels, right? And just like with Django REST framework views, you can always extend a view, right? Or a view or a class view with something like maybe API view and so on and so forth, list API view and so on. So that's sort of how I look at this thing. Okay, so accepting connections, right? So let's say you just logged in, you've been authenticated, right? And now you're looking at your view and your map, right? And you want to be able to view everything that's currently happening with regards to streams, like the streams that are currently happening, or the broadcasts from the tracking devices and so on and so forth, right? And seeing that you want that to happen live, you need to upgrade a request, right? You need to upgrade to WebSocket. So what you do is you send you create a WebSocket, right? You create a WebSocket instance in whatever language or whatever framework or tool you're using, and then you initiate the upgrade request, right? And along with that, right, if you're a user, right, what happens is, by virtue of you being authenticated, right? I know this is like a security flaw, right? It's like a security flaw, but by virtue of you being authenticated, right? By virtue of you being authenticated, when you upgrade in your WebSocket request, right, there's no need for you to pass any credentials, right? That's a security flaw, but it's something that's pretty easy to patch up along the way. So that's one part, right? So that's the user's part, right? So if you're a user, you log in, right, successfully, right? And as soon as you've logged in, right, a WebSocket connection is created between you and the API, right? And then that WebSocket connection is actually ready to start receiving anything that it can, right? Or receiving the data that it's actually, waiting for, right? Or that it can receive, or that it should receive, So it's one part, right? That's the user's part done, right? For devices, now considering how we have multiple devices, or how you can have multiple devices in the field or out in the wild, right? Needed a way to be able to establish a connection, right, to a device, right, and also allow for the device to establish a new connection, right? Let's say after, like, when it turns back on again after it's been turned off and so on, like a way to be able to identify which device this is, right? So coming back to routing, right? Coming back to routing, this second path right here, right, is dedicated to devices, right? So client type and client UID. So both these paths, they do have client type, right? But the device actually has client ID, right? Client UID. So when an upgrade request comes in and we have to establish a connection, right? Here's what happens, right? First of all, I declare a global, in a sense, room group name, and I just call it watchers, right? I should have called it washers, but that's fine. Data. So the data that I'm looking for, right, or the data that I want when a request comes in, right, it resides in the keyword arguments of it resides in scope, right, URL route, and in the keyword arguments, right? That's where it resides. And then from there, from this data, I want to get the client type, right? So I say data client type, right? So regardless of whether it's the device that's sending the request, right, or that's sending a request to the API to establish a WebSocket connection, or the front end the front end on the or the front end rather, that's sending a request to the API to establish a connection, right? Both of those will have to have a client type, and that client type can either be device or user, right? So client type right there, right? And then if the client type is a device, right? If the client type is a device, right? Then I'll come to the client UID, right? I'll search for the client UID, right? I'll say, okay, client UID, I need data's client UID. So in this data, I want client UID, and this client UID, it's this client UID, right? So then from there, what we'll do is declare variable device, and then check if this device actually exists, right? Do we have a device with this particular UID, right? And then if the device exists, right, and we say true, right, if device, or should I say if device, then we accept the connection, right? And we accept the connection. And then if it's a user, right, if client type is user, right, client type is user, then we simply add that user to this group, right? We add that user's channel to that group, and then we accept the connection. That's it, right? So if none of these three are met, right, we'll just fall through and then disconnect, right? We just fall through and disconnect. So now, if you've read the Django channels documentation, right, let me just pull it up right now. The documentation, right? Django channels documentation, right? There we go. So when it comes to database access, right? So most of the times, most of the times, right? You'll find that with WebSocket with WebSocket connections, right? You want to either do something, you want to do very small things quickly, right? Or you want to do some things, right, in the background, right? So, for example, let's say you just want to send forward, right, or you just want to broadcast to a particular group, right, a particular piece of text or a notification or message, right? You can do that quickly, right? You can do that quickly, such that you can even do that synchronously, right? But then when you have to take that message, write it to a database, right? And at any point in time, or at some point in time, or at like a worst case scenario, you have, let's say, hundreds and thousands, or even millions of those, in a span of a second or a couple of seconds, right? You need to be able to shove things off to the background, right? So to do some of the things like asynchronously, right? So that's where Django channels async and sync comes in, right? So Django channels, there's WebSocket consumer, and then there's async WebSocket consumer, right? It's coming with documentation right here. Consumers. Okay, Django channels documentation on consumer says, while channels is built around a basic low-level spec called ASGI, it's more designed for interoperability than for writing complex applications in. So, channels provides you with consumers a rich abstraction that allows you to make ASGI applications easily. Consumers do a couple of things in particular. Structure your code as a series of functions to be called whenever an event happens, rather than making you write an event loop, and so on and so on and so forth. The basic layout of a consumer. So we have a sync consumer right here, right? So if we can see a bit of a difference here. So sync consumer is a synchronous consumer. So sync, right, synchronous. When you're using a synchronous consumer, you don't need to prefix with the keyword async. So you can just write everything right there, just write everything right there. So you want to broadcast a text or a notification to a particular group, or small set, or a large set, once every couple of seconds, right? Or just once. You can always use it like synchronously, right? So sync. And then you have async, right? So async consumer. Okay, the async consumer is laid out very similarly, but all the handler methods must be coroutines, and self-send is a coroutine. So we'll get to that one a little later. Or how about, just for time's sake, I just let you guys, read the documentation. I'll try to leave a link to the documentation, or you can always just Google it like I did, and find it. But this document right here, or this page right here, it's really useful if you're trying to make things happen with Django channels. It helped me build this whole system. As much as I was almost BSing, like in most areas, right? The scope of it, right? Just the scope of it actually made quite a lot of sense, and it helped quite a lot. So I suggest that you read the documentation, and then you can maybe come back to this video, or you could do whatever you like. That'll be up to you to decide. So anyway, continuing from here. God, I talk too much. Anyway, so watch yourself room. I think I've already gone through this, right? So asynchronously, right? For async operations, like let's say you're running a function or you're calling a function, you have to await, right? You have to await self, get self, and then you run the functions. You run the function, and then you get the parameters, and then away you go with it, right? So this function calls to a database, right? So if I come right here, this is the function right here, and I had to use a decorator, right? Decorator, and it's one of channels decorator, Django channels decorator, database sync to async, right? And run it, declare it, your attributes, right? Or your arguments actually, your arguments, UID, and seeing that I'm getting device, I check with the ORM. Device objects filter UID. If it exists, it will return true. If it does not exist, it will return false. And then I run that, right? If device is false, then it will fall through and just run that and disconnect. So same as almost everything else over here, right? Get device, right? I'll come back to this. I'll come back to this really soon. So this is what we have right here. Right? This right here is it's what we have right now. So we have right now. The intricacies of how most of this happens, I'm pretty sure you can understand it. When it comes to writing, right, as long as you have declared that decorator, the logic down here it's pretty much going to have to be the same. It's pretty much going to be the same, right, as when you would do it using a view, a class-based view, or a function view on the other side, right? User exists, receive, right? So when the tracker sends something, right, the receive function will handle it, right? So async def receive, it will handle it, right? So text data default is 9, bytes data default is 9. So what you do is seeing that I'm sending a JSON string, right? I just load that JSON string, load it into, let's say, a dictionary, right? Make it a dictionary, and then I send it to write, right? I send it to write, right? I take that data that has been sent, and then I write it to the database, right? Which is where all of this happens. And then I say to Django channels, send this to everybody in the group, right? Send this to everybody, like to everyone, or to each and every channel in this group, right? So which is exactly what she does right here, right? Type broadcast, so she runs this, right, and sends that message to everybody, just like that, right? Okay. I think that's pretty much it. That right there is pretty much it for our consumer, right? That's it for our consumer. So to round up the consumer, right? It's asynchronous, right? It's synchronous. So what we do is when we upgrade a connection, right? When we're upgrading a connection, we check if one is it a user or a device, right? If it's a device, then we get the client type and the client UID, right? And we check if that UID corresponds to a device that we have in the database, right? If we have that device, right, then we accept that connection, right? That's the devices, right? For the user, right? For the users, granted that actually not granted, seeing that in order for a user to be able to upgrade to a Websocket connection, they need to be logged in, right? What that means is What that means is actually what that allowed me to do was to not really bother, with trying to put some safeguards on authentication, because in order for me to be able to identify the user, I'd have needed to submit some type of a credential right there, right? So I'd have said, okay, user, and then maybe given the user UID right there, and then, yeah, it works, but then there's still some flaws to that. So we keep that in mind for now. Keep that in mind. We'll wait for security best practices to be, let's say, published and made well known with regards to WebSockets. Next, consumer routing. Next, we have our models, right? Our models here are, I have geofences, devices. I'm going to forget about trip. Yeah, I'm going to forget about trip, right? So I have geofences, I have devices, and I have device location, right? So geofences, we could just call these like spatial representations or spatial representations of let's say a geographical area, right? A geographical area. So you can always uh, draw up a geofence in a sense, or represent a geofence of, let's say, a city, right? By placing points in particular location, and then linking those points and creating sort of a polygon, right? And creating a polygon that will then represent or visually represent that area. So best. So UID, name, is active, and geometry. Geometry, as I've already explained, polygon, right? So I'll show you how it works. Str, it's just a string representation of it, which just gets that, and then that's that. Device, this right here is our tracking device, right? This right here is our tracking device. UID, can always do away with that. Oops. UID, and then we have models, right? Which is UUID. Code, device code, right? Which has to be unique. MAC address, the MAC address of the NIC in the device. Package, the package which that tracking device is tied to, right? This right here would have changed, could actually have changed this. It's just that the implementation actually required us to have that. Description, just a short device description. Last location of the device, right? And geofence that this device is actually, attached to or assigned to. Device location. So each and every time a device sends something, right? Each and every time a device broadcasts its location, that location is actually stored here as device location. So we have UUID, device, the location, whether or not it's in its designated geofence, right? The speed it's traveling at, number of satellites that are actually that actually helped with the triangulation, and the date received, right? So I'm pretty sure you can imagine that how this can also be used to create like reports in a sense, right? Can create particular report. So that's a good thing. So that's one part. Right, there's one part. I'm not gonna go into serializers because I'm pretty sure everybody, like, if you're watching this, you understand the concept of serializers. So I'll simply make references to the serializers and what I'm doing with that particular serializer. So before we get to views, let's come to URLs. URLs, I have devices, right? I have the first path right here, which pretty much goes to index, I think, yeah. And then I have devices, right? devices, this one right here gives you a list of all the devices, right? And then device, this first device right here, what it does is I use it to add a device. I know you can do that with class-based views, but then sometimes there's some intricacies that you want to explore, with other options, right? So that's device. So if you check this device right here, if you check this path right here and this path right there, they're actually sort of the same model. So this one right here, it's for post requests, right? When you're creating a device, right? So you're sending a post request. There's nothing on there are no keyword arguments on the URL route. So you're just sending that data to create a new device. Next we have a device which actually has keyword arguments, and this right here, it's for update, put and delete, right? That's what that is about. Report. Report, this right here is for generating like sort of reports, actually for generating reports. So what it would take is a UID, so it's a report on that particular device, right? That particular device's reports, the start date and the end date, right? And then it goes to DLH, device location history view, right? Geofences. This one actually lists all the geofences. And then this one here, it's to update, delete, geofences, right? And maybe read a specific geofence. And then geofence, this one right here, it's to create a geofence. So sending a post request with all the credentials of a particular geofence. That's what this path is for. Okay. So I'm gonna take a break and be with you in about a second or two or three. So see you in a bit. Right. Welcome back. So now we're going to do our views. Just going to run through our views, right? For track especially. So tip, if you've used Django class-based views like Django REST framework with the generic views, I think, yeah, the concept here is just the same. It's just the same. I won't lie to you or try to waste your time and be like, oh no, there's a fancy way of doing A, B, C, D, E. There's a fancy way right here in which I did a lot of things. Most of this, it's simple, it's easy to read, and it's easy to understand. So don't feel down when it comes to that. Don't feel down when it comes to that. So I'm just going to run through this quickly, right? I will spend a bit more time in explaining to you like how a couple of things work, and then from there we can always move on to the next thing. So the things that I'm not going to cover right here, right? Things that I'm not going to cover right here, right? Vehicle, which is the just basic fleet management, right? I'm not going to cover package, right? And I'm not going to cover user, right? The user app, right? Because all of that is just peripheral, right? All of that is just peripheral, and it's not necessary if you're actually going to use what I'm trying to explain to you here to, build a tracking system, right? So don't do that, don't don't be too focused on those things. If you already understand how the Django REST framework works, how it functions, then everything else will pretty much come together. Okay, so enough talking. Let's get to this. Okay, so with views, right? I have a device view, right? So views, right? Previously, before the break, I walked you through the URL patterns, and I'm just gonna walk you through the views, and it sort of builds from that. So let's go. Device view, right? In device view, I have post, right? And I'm simply taking the data from device view, right? And I'm serializing the data, right? Checking if it's valid and saving it, right? So now there's a section here, this section right here, right? So first of all, the geofence, right? I try to get the geofence, right? I try to get the geofence, and then when I have the geofence now, right? When I have the geofence, I want to get the geometry of that geofence, right? Because I need to at least supply like some location for this particular device, you know. So geofence, right? I take the geofence, I pass it as GeoJSON, right? And then seeing that it's GeoJSON, it means I can actually index it like a multi-dim array. So I create a point and I say, okay, point will be a tuple of the very first coordinates in this GeoJSON, right? That's it, the very first coordinates. And then that point that I have created will become my last location, right? As much as it's a new device. So that's one way. And then geofence, polygon ID, package, that will be package ID, and we're good. Okay, and then back to that again, Django tradition, serialize, right? Check if it's valid. If it's valid, save. And you can always raise exception and then return a 201 created. That's that. And permission classes, it's is authenticated, so you have to be authenticated in order to do this. So keep that in mind. Put request, it's just like at the top, right? It's just like the top, but then the only thing that you're doing here is the only different thing that you're doing here is you have a device, right? You declare your device, right? You declare your device and you say, yeah, you declare your device, and then in your serializer, in the instance, right? In the instance variable, in the instance argument, right? You just pass in that device as like the current instance of this particular record, right? Or the current instance prior to updating, right? And then you give your data and you set whether or not it's partial or true. So if you're partially updating the model, right, then you have to do that. If you're updating the entire model every time, then you might not really need to supply that. And according to tradition, you validate, right? If it's valid, then you update the instance with the validated data, right? So update the instance with the serializer's validated data. You save that and then you return an OK. Delete, pretty much the same thing. You need to be authenticated, right? Check if the device actually exists, right? Then if the device exists, you delete and then you return a no content, right? Now devices, right? So devices returns a list of devices, so the list of all devices. And then you have a pagination, you have a permission class is authenticated. We don't want everybody to see anything about our devices, so you have to be authenticated. Pagination class, you have a page number pagination. Query set, you're getting all devices, and that's your query set. And then you give your serializer class, and there you go, you're done with that. Device location history. So DLH, I call it DLH, or device location history. It's a list API view. Permission class is authenticated. You need to be authenticated. And then format, it's a year, month, and date, right? So what I do is I take the start date that I've been given, right, or the start date of the request. Then I format it in accordance to that, and I take the end date and then I format it in accordance to that, right, to that format. And then I set a date range, right? I say, okay, start here and end here, right? That's my date range right there. And then now, seeing that in my device location, I have probably millions or thousands of records, right? And I need to be able to get the right records within a particular period, right? I need to filter. So device location objects filter device UID, and in device UID we get the keyword arguments of the request, and we get the UID keyword argument. And then I say, okay, date received range. So I want everything that was received within the start date, like between or starting from and ending at the start date and the end date, right? That's it, right? And then I return that as my query. So if there is nothing, you get nothing. Pagination class, we got that page number pagination. Serializer class, and then we got that. So Django will simply work the magic right there and make things happen. So yeah, I could build the whole thing on my own, but nah, wouldn't want to. Why do it when you have this? API get list geofences. Here I've had to list geofences, right? So query, go to geofence objects, get all geofences, serializers, it's geofence serializers. Instance, the instance is going to be query, many is going to be true, and then we'll simply return the data from there. That's that. Now, next, geofence view. Now this is the fun part. I must say, this right here is actually the fun part. It's actually the fun part. Now, geofences. In order for you to create a geofence, you need all those attributes, right? But one tends to be a problem, which is the geometry, right? So now you need to be able to take your geometry from you need to be able to take the geometry from whatever you've used to design whatever you've used to define the geometry, right? And bring it to Django, right? And bring it to Django actually. Yeah. So you need to make sure that it's in the right format, right? You make sure that it's in the right format. And it's also yeah, it's just the format actually. You make sure that it's in the right format and it's in the right structure also, right? So I'll have to explain that when we're working on the UI, when I'm walking you through the UI, right? Let's do that. So right here, right, a couple of things to note, right? So I have geometry that actually gets submitted, right? This geometry that actually gets submitted, which is a 2D array of coordinates, right? 2D array of coordinates. So now what I do is get in there, right? Take each and every index, right? Take each and every item, right, of those coordinates, turn it to a tuple, right? And then append it to an array or a list, right? Append it to a list. And then from there, declare variable of geometry, and take that list and pass it off as a tuple. And then we can always go back to data and declare geometry and say, okay, geometry is equal to, geometry will be the polygon, right? Geometry will be the polygon of this tuple, right? And then we go to Django tradition. We go to Django tradition and we say serializer, right? We serialize the data, validate it. If it's valid, we save, and then we send back a response. Whew. Put is the same thing, and yeah, put is the same thing. However, now with put, right? With put, just like what we did with put in the previous slide with the device, right? With the devices, we get new geometry, right? And we take that new geometry, we add it to the data that we've been given, right? Or the data object, right, that has been created from the request, right? We take that new thing, we take that new geometry, and we append it to a polygon, and then we append that polygon to a data object, right? In this case, it's a data geometry, and then we take that polygon and we pass geometry in, and then we go back to tradition, right? We go back to tradition, and then that actually sums up most of how this thing is working. All right then. Now let's test this system. Like let's test it. Let's get another walkthrough and an actual demonstration of what's actually going on here. So what I'll do is I'll come right here and I'll say Toyo. I'll have to run this in a terminal. Ooh. Let's source then activate, and then we'll say now to come over here and just say, where's that thing? I am just running the server. Manage by run server. Okay. Now my server is running. I know it's running. Yeah, it's running at the right port. Okay. And then I'll come right here. I need to check my IP address now. Cool. Right. Now, let's have me test the system out for you. I also need to run that. No. Webstone projects. Serve num can't be the only one that makes that mistake. And writes gnome instead of npm. Like nope, can't serve. That's pretty funny. Okay, this right here is the emulator. We'll walk you through it. What we do in the front end. And I'm walking you through the front end, so it should probably be tomorrow. Cool. Use crow. Okay, now in 7001 I need 80. Duplicate 80. So now let's see if we can establish a WebSocket connection right here. Okay, she's still building this thing. So this right here is just the start page for the API. It's just nothing fancy. Okay, now here we go. Cool. 125. I hope this is visible. Yeah, what's up? I think I might know where this problem is coming from. Okay. Oh, this one's 80. So it should have been 8,000. Cool. Okay, save that. Should log in from here. XHR, what happened? Okay, that's the problem. Yes, I do trust it. I just need to change one little thing in this side. Constants. Cool. Alright, as soon as that loads up, that should be enough. Okay. Login. Failed. Yeah, talking about 106. Okay, I see. Let me get the IP address. 108. Yeah, IP addresses can really get your head spinning. Really send your head spinning all over the place. Okay, log in. Okay. Okay. Now we're in. Just save that temporarily. So while we're at it right here, we'll have to walk you through a couple of things. Okay, first things first, exit that, let's come right here. Okay, so when a device, right, when a device sends a when a device sends a request to when a device sends a request to the API, right, it needs to provide everything, right? It needs to provide almost everything. So device type and the UID. Right here it says channels radius, no margin name, channels radius. What's your issue? Sorry about this fiasco. Channels radius. Okay. Run server, please. Okay. I didn't mean to debug live. Okay, so that's what we needed. That's what I needed. That's what we needed. So now if you can sort of focus your eyes on this little section right here. Right, if you can focus your eyes on this little section right here, right? WebSocket handshaking, socket io/user, right? You focus on that. Right. Let me see if I can log out if I did add that here. Okay. Right. Okie dokie. Right, let me clear this out so we can see this thing in action. So we're gonna run our server, and our server is ready. And then I'm going to log in, right? So I want to show you the sequence of events as this thing actually happens. Okay, cool. So post auth sign in, auth the user gets the auth user details, and then after that we upgrade a connection. So handshaking and socket, right? Then we establish a WebSocket. and then this one is connected. Right, it's been accepted. It's been accepted. So it's one part, right? It's one part. Now, when it comes to devices, when it comes to these devices, I want to close that 100%. Okay, yeah, that should be fine. So now I have my map right here, world map. So I'll come over here and geofences, right? So these red markers or these red shapes, right? These are actually the geofences, right? It's actually geofences. So before we get to geofences, let me just walk you through what's actually going on here. Right, so devices, come right there, click on devices, and then you have all of your devices right here, right? So PRJ1, motor 2 or mod 2, right? TST001, then we have that, DPRJ02, and battery 001, right? So PRJ, it's this, right? So in a case where you just have a lot of markers right here, you can always figure out which one you're looking for, right? There's that marker, which is the home marker. This is motor, right? You can also see the update right there on the focus marker. And then you have this marker right here, right? Which is TST. Then you have PRJ001. Then for the find our battery, here's our batteries right here. Right. So we got right about now. So just to walk you through what I'm going to maybe run you through when we're talking about the front end. Next time we talk about the front end, I'll be demonstrating to you how to actually retrieve data from the back and so on. So we're actually going to get into like how we're going to use Postman and all of that stuff, sort of test endpoints and stuff like that. We are going to do that. So just to demonstrate one more time, like how this whole system works, right? How this system works with regards to, let's say, WebSockets, right? And live streaming, actually. With regards to live streaming, I'm going to come right here. I need a 5500. 5501. Okay, I've got this little thing right here, which is which is sort of an emulator, right? Which is my emulator. So I sort of use it to emulate a tracking device, something like that. Okay, so it hasn't found this IP address because I'd actually been running this emulator using my laptop. So network JS WebSockets no type error hazard 127001. Okay, that's what I'm going to use. Come right here. So yeah, you might find yourself battling with a lot of IP addresses at some point. If I say true, same is true, I'll use that. Same is true, same is true. WS, I'm not really concerned about that, so we'll leave that. Most definitely, yep. We should be set. So if I come to test, right, if you can see this WebSocket connection, WS, that devices or socket IO device, and then the device UID, it says it failed, right? So 552A34 going to look for that in our logs. 52A34, which is the last thing, it failed, right? Disconnect, right? So for whatever reason, it actually did disconnect, right? So could be that one, the device wasn't found, or it's the endpoint, right? But then right here, I'm not seeing anything on the endpoints. So let's come to this side, track, routing. Yes, most definitely is that. So we'll save that. Cool. And then let's come to you and let's reload again. Says it's ready, probably because it found the default device that we'd set right there. So network WS connected, length is 9. And then this one also, which is 101 switching protocols, which means it's okay. Upgrade WebSocket server is definitely, and so on and so forth. Look into that one when we are building this. This is just a walkthrough, like I said. Now I'm going to come to my admin panel just to demonstrate to you how this whole thing works. Basically, I'm going to come to devices. I want to take this projector and then do that like so, Alright, take the UUID, right, or the UID 52A34, that's fine. Same UID. Well, let me get another one, actually, different UID. I'll take the batteries. Cool. Take this, come over here, then say I'm supposed to come over here, move that there. And then in my little emulator, I'll just set it to do 3 seconds, right? 3-second intervals with this device ID, right? Then we'll start a transmission, right? But before I start my transmission, let me just clean up this view a little bit. Then we'll do that. Cool. And then while we're at it with that, we're going to come to WebSockets. Yes, I do have that WebSocket connection. Type is okay, hash is that, blah blah blah, and all of that stuff. And then I've got user, which also upgraded properly. So focus on messages. That's what we're going to focus on right now. Just going to consider our messages. Close that. So most probably down here with messages. Now this thing is too thick. Okay. Alright, I think that should be fine right there without causing too much havoc here. Right, so now we're going to start our stream, right? And then we just come right here and we say start transmission, right? So we do start transmission, wait 3 seconds, we should be able to see something here. No, right here. Is it WS connected? No, it's fine. No, it should be fine. There's 003, that one is certain, just fine. Okay, I'm going to establish a new connection. Do that. 3 0 0. That has data. 3, let's go. 2 3. Okay, there it is. Right. There it is. It's weird. The initial request got upgraded properly, so now it's just taking the UUID that's currently there. Okay, that's fine. So every 3 seconds we see a transmission, every 3 seconds we see a transmission. Okay, if you give me a second. Okay. So I said every 3 seconds there's a transmission, every 3 seconds there's a transmission. Now, in each and every transmission that happens here, there's an update this side, right? So I'll come to devices and then I'll need you to watch one of these devices, right? Just watch one of them, should be a change, and it's battery 01, right? Which keeps moving. So it's every 3 seconds, there's a shift, every 3 seconds, there's a shift, every 3 seconds, 3 seconds, 3 seconds, 3 seconds, right? So we got. Okay, so every 3 seconds it broadcasts, every 3 seconds it broadcasts, every 3 seconds is a broadcast. And you can also see the data coming in over here, right? 3 seconds, 3 seconds, 3 seconds, 3 seconds, 3 seconds, right? And then you can also come to the side and say, okay, change this to 1 second. Every second, I want to see something every second, right? And it will start moving a lot faster, right? Start moving a lot faster. You see. So, recap, right? Just a short recap. You have Django channels, right? And then you have your REST framework, right? There's two systems, there's the front end and the back end, right? And these two are married to each other, right? So the tracker, right? The tracker creates or it initiates a WebSocket connection, right? And then as soon as the WebSocket connection is established, right, the tracker can then on set and specific intervals, right? On certain specific intervals, the tracker will send data, right? The tracker will send its location on specific intervals, right? So if it's 5 minutes, then it's going to be 5 minutes. If it's 10 minutes, then it's going to be 10 minutes. If it's a second, then it's going to have to be a second, right? That's what we have got, right? Sure, you can decide to go with UDP and so on and so forth, right? That's all right. But then WebSockets, they just work most of the times. Like, they just work. Only gripes that I have with WebSockets is when it comes to security. When it comes to security and authentication, authorization, and so on, you need to handle that on your own. I don't think at the moment there are facilities to be able to handle that stuff. So that's all we've got right now, and this is a system that we have. It's a proof of concept. It is possible. It is very much possible. You're only limited precisely by your dedication and imagination. That's mostly it. It's mostly it. So before I seal this off, right? Before I seal this off, I'd like to walk you through the geofences, right? Because that's one of the major features of this little thing right here. So geofences, right? So come to options and geofences, show geofences. Home fence, this is my home fence right here. Then yes, it's very nice. test zone, let's show you as a test zone, right? Then clicks of fence, this is clicks of fence, and this is what we've got, right? That's what we've got. So what I'm going to do is I'm going to show you how these geofences work, right? Just briefly, just give you a hint of how we made this happen, right? And before I get there, I'd like to thank a really good friend of mine, Tabelani. She actually helped me quite a lot with, especially with the mock-up of the system. She really did a great job. On that, let's go on and start talking to these geofences. So I'm going to use the test zone right now. So each and every point on these each and every point on the geofence, right? Each and every point on the geofence, it's represented by one of these markers right here. Represented by one of these markers. So when you move a marker to a particular location, right, the shape changes such that the vertex that marker represented, right, is moved to that marker's location, right? For example, let me move this, right, to exclude bronchosprate, right, like that, just like that, right? So that's what happens. Sort of what happens. So if I move that to there, move that to there, and that to there, that to there, there, move that to there, and there, and there, you know. So you will have that. So the other thing, I'm pretty sure you can see that when I do something like this, right, there's it messes up the shape, right? So in some vertices, actually, in just a set of vertices, the main vertices, actually, like the first vertices, right, there's two markers and these two markers overlap. So when I move the markers, this actually happens, like that actually happens, you know. So these markers actually represent the same vertex, which is why when I move them around in a certain manner, right, after they've, let's say, overlapped, right, they always like come back together. So these markers, they always represent the first vertex. So what happens then with these polygons is when you send that data, right, when you're sending the data of these polygons to the API, right, what it requires, right, or what is required by the polygons is that the first coordinate, right, should be the same as the last coordinate. That way it sort of seals that whole thing and doesn't leave it open-ended, or just, you know, yeah, it doesn't leave it like open-ended. So which is why this right here, right, some of these markers, they are actually, you know, the same. I'm trying to get that thing to happen again, but it's not happening. It's not happening. But I'm pretty sure you get the idea. I'm pretty sure you get the idea. So for some of these markers, like some of these markers, they represent a single point, but then the first and the last marker are actually in the same position, right? So keep that in mind. Keep that in mind. So let me just edit this and just show you how this thing really works. I'm just going to exclude bronchosprate right there. Well, let me just put it around bronchosprate. That should be fine. Like so. You know. So let's say you're never allowed to leave this place. Like, you are never allowed to leave this place, be it you're driving and so on and so forth. You cannot leave this place or this area. Then it's like, if the tracker ever leaves this area, then you can always, put down the logic to maybe get an email, an SMS, or an alarm, and something like that, something of that nature. So currently, Bronco Sprite, what should look like. Let me duplicate this tab, come over here. This is what it looks like right now, right? Then if I save, right, let me also show you how this data leaves for that side, how this data is sent. So I'll come right here, I'll say XHR, and let me just get all. So I'll save, and then this is what we got. Pre-flight to look like that, response, payload, right, payload, geometry, this is my geometry right here. So if you can see, the last one is just like the first one. Not sure if my highlighting is actually, pretty clear and visible, but geometry, first item, there's our first item, our last item, it's just like our first item, right? So that is what we have got. So that's sort of how these geofences are represented, right? So next we'll be getting into the front end, like how this whole thing came together, especially on how this geofence is actually really got to work, how we got these things to work. So keep that in mind, sort of keep that in mind. So now that this right here has been updated, right, if I just come over here and let's say okay, I'll just close this page anyway, I don't need it. If I go back home, I don't know if you saw that, but Broncos quickly changed, right? And that's what we've got. That right there is what we have. So we have. And this one is still moving. And close that. So yeah. So what we got. This is what we have, ladies and gentlemen. Our tracking system. I do understand that I did not go into details about things like the staff, the staff section, or the vehicle management and so on and so forth. But I realized that if I had actually gone into that, I would have been explaining like I'll be repeating myself. I'll be repeating myself because the concept throughout is it's the same. The main concept, it's just the same. So I would really sort of appreciate feedback on this. I'm still trying to figure out how I could how I can come back to this project and say, let me rebuild it in a sense. I'm still trying to figure out a use case for that. Try to figure out a use case for that. So if any of you have any ideas on, let's say, a use case for such a system, might consider actually sitting down and doing a series where I actually go through building the thing. Yeah, apart from that, there isn't really anything else. So all I can say is, well, thank you for watching, for being with me on in this session, right? And looking forward to hearing from you what you have to say, and stay safe and have yourselves a good time. See ya.